Hello friends, in this video we'll discuss a theoretical topic but very conceptual and important. This topic is very important for your any kind of competitive exam. We'll discuss about two very important types of instruction set architectures. Number one, RISC, RISC. Number two, CISC, CISC. In this video, we'll discuss in detail about this both instruction set architectures. We'll see some of the advantages and disadvantages of both the architectures. I hope you like this video, and if so, then please do subscribe the channel. Let's start the video. Before we move on for the actual topic of discussion, let me ask you a very simple question. If I ask you, did you ever hear about a word called ISA? The full form of ISA is Instruction Set Architecture. Now many of you will answer yes sir, we heard about this term many times, Instruction Set Architecture, in short ISA. Now what is ISA? See, whenever we execute some program or for any type of program execution, we need to execute some instructions, right? Program is nothing but a set of instructions. Now in our system or in our computer, we have a predefined set of instructions. Those instructions your computer can handle or execute. You understood that? That means in our computer, we have a set of predefined instructions. So only those set of instructions or those type of instructions your computer can handle. It's not that you will write anything as instruction and your computer will be able to understand or execute it. No, we have a set of instructions which are already there. So based on the set of instructions, whichever your computer is able to perform or able to execute, we can divide our computer into two different types. The first one is known as RISC, or the full form of RISC is Reduced Instruction Set Computers. And the second one is CISC, which is Complex Instruction Set Computers. Now what is RISC, what is CISC, we will discuss in today's video. So let's start the discussion one by one. Initially we will discuss about CISC approach or the CISC type of computers or CISC type of instructions. Then we'll go for RISC type. Fine. So what is CISC type of computer or CISC type of instructions? The primary goal of CISC architecture is to complete a task in a few lines of assembly as possible. What did you understand from this word? Means CISC type of architecture allows you to minimize the length of your program or length of your program. Whenever I am saying length of your program means number of instructions will be less, few number of instructions are sufficient to execute the program. How? We'll see with the help of some examples. In the upcoming slides we have some examples also. This is achieved by building a processor hardware that is capable of understanding and executing a series of operations. See, whenever I am saying minimize the number of instructions, say I have initially 10 different instructions for a single program. Now I am asking you, I don't want these 10 different instructions. Just execute the same program in 5 instructions. I don't have much memory to store these 10 different instructions. Make it to 5. Now what you have to do? Now you have to change in the hardware so that your hardware can understand some complex instructions. Now the instructions, if you make it short, operation is same. The goal or the program goal is same. Whatever I am saying, just to reduce the number of instructions. Then what you have to do? What is the alternate way? You make it shorter, but in each line or each instruction, you have to make some complex decision so that one line can perform multiple tasks, right? So ultimately we are making the instructions complex. Fine. So we'll discuss this concept with the help of one simple example. So this is the operation. I want to perform C equals to A plus B. Now if I ask you to write or represent the same code in CISC, how to write? This is how we write. Move B R1 comma B means whatever they are inside B is nothing but the memory location. This is not the registers. So whatever they are in memory location B, I will move to register R1, then add R1 comma A. So whatever they are in my memory location A, I will directly add it to R1 register where I already have B. So it is nothing but R1 equals to R1 plus A, means R1 equals to B plus A, right? And finally I will store back the same result to memory location C. So this is how I will write move R1 comma C. So whatever there inside R1, you just move it back to C. Now from this example, you may not get such much differences between RISC and CISC. You will come to know very soon what are the major differences. First thing you can note it here is move. This move keyword is used in CISC type of instructions. For RISC, we always use load or store. Fine, can you remember that? Now let me take one more example. It will be more clear for you. Suppose I want to perform one multiplication operation. What is the multiplication operation? Maybe I have some data in my memory location 2, 3. Means maybe row number 2, column number 3 and row number 5, column number 2. So I have these two data in my memory. You can directly put the addresses also. I am putting the location direction. You can put the address also like A comma B also. It's fine. Suppose I don't know this exact location, but I know the coordinate. So this is how I am writing. Same thing. So second row, third column, fifth row, second column. These are the two memory locations I want to access, and I want to multiply the data whatever they are inside these two locations in our computer. This is the program I want to run. Multiplication of two numbers or two data which are present in these two different memory locations. Now for a CISC approach or CISC architecture, to perform this whole operation to multiply these two data or two numbers, we don't have to write a series of instructions. Only one instruction is enough to make your processor understand about the operation. What is that? This mult, M-U-L-T. If you use this keyword mult, this keyword is a complex keyword, or whenever you are writing mult, your processor will understand that the instruction is a complex instruction. Means this is not a simple or straightforward instruction. I have to perform many things whenever I am giving such kind of keyword, complex keyword. So using the simple or single line of instruction, my processor will be able to understand what is the main task, and it can perform the operation. It can directly access the data from main memory, and it can perform the multiplication. Understood that? So this mult is what is known as a complex instruction. It operates directly on the computer's memory banks and does not require the programmer to explicitly call any loading or storing functions. Did you understand that? So in CISC approach, if you want to perform some operation, you can directly access the data from main memory. You understand that? Your instruction, whenever you are writing some instruction in CISC, your processor will understand, okay, I have to access something from main memory, so I can directly access. I don't have to load the data to registers first to perform the operation. I can directly access the data from main memory and I can perform the operation in CISC. Fine. For instance, if we let A represent the value of this location, second row, third column, and B represent the value of fifth row, second column, then this command is almost same with the C statement A equals to A into B. Understood that? I hope it's clear for you. Now let's see some of the characteristics of CISC approach. So one of the primary advantages of this system is that the compiler has to do very little work to translate a high-level language statement into assembly, right? Because you have only one line of instructions, no need to take much headache to compile it to assembly language, right? One instruction or one line is sufficient for the entire program. Because the length of the code is short, relatively short, very little RAM is required. You agree with that? Because only one line of instruction I have. So to store this program, I need only one memory word maybe. I don't know how many memory words I need. For simplicity, I am taking one memory word is necessary. So number of word or the overall RAM is required, less RAM is required to store such instructions, right? Only 1 or 2 lines are sufficient to store the whole program. Fine. CISC style can be characterized by, these are the major properties. First one is more complex addressing modes. Now what is addressing modes? In the next video we'll discuss. So as of now, please skip this word addressing modes. More complex instructions, as we already discussed, where an instruction may span multiple words. Now the problem is, although we have only one instruction, now I cannot say that my instruction will occupy only one word from the main memory. No, you cannot say. Since my instruction is complex, I don't know how complex it is. It may be very complex. If it is more complex, then I need more memory word to store the instruction. I cannot store the whole instruction in one word every time. It may take more than one word also. Fine. Arithmetic and logic operations that can be performed on memory operands as well as operands in the processor registers. So it can perform the ALU operations directly accessing the data from main memory or in registers also. So both the way it can perform the ALU operations. Transfers from one memory location to another by using a single move instruction. One move instruction is sufficient to let your processor know that I want something from this location of memory to that location of memory. Fine. Programs that end to be smaller in size because fewer but more complex instructions are needed to perform complex tasks. So this line I already discussed. Because I have less number of instructions, then overall program size will be smaller. Fine. Some more features. CISC may take longer than a single clock cycle to execute the code. You have to remember that. Since your instruction is complex in the sense there are multiple operations which are associated with a single instruction, right? That means if you execute a single instruction, it may take more than one clock cycle because there are multiple operations it will perform for a single instruction. So it may take more than a single clock cycle to execute a single instruction in CISC. Fine. The length of the code is short. I know the overall length of the code is short because the instructions are complex. One instruction can perform multiple tasks. So it requires minimum or minimal RAM. I already discussed. It comprises fewer registers and more addressing modes, typically 5 to 20. Forget about addressing modes now. I will discuss in upcoming videos. Now what it says, it comprises fewer registers. Obviously I need very few registers, right? Why to waste the register? Because I don't have to load the data from main memory to register to perform any operation. I can directly operate on main memory location. So I won't load from main memory to register. So overall I need very few registers to store the data, right? Because I can directly work on memory. Why shall I load it? So less number of registers are required. So let's see some of the advantages and disadvantages of CISC. So if I talk about advantages, the first advantage is reduced code size. Obviously the overall code size will be smaller. More memory efficient because it's smaller, so I need less memory to store the program. Then widely used. So most of the computers support this CISC architecture. Fine. Now what are the disadvantages? Let us see. First one is slower execution. Why I am saying slower execution? Few minutes back only I told you, in CISC I cannot say that each instruction to execute one instruction it will take only one clock cycle. No, it may take more than one clock cycle also, right? That means overall if I want to execute a single instruction, then in CISC it may take longer time than other architecture which we will discuss. Fine. Next is more complex designing. Obviously because you are executing some complex instructions, so your processor also need to understand the complex instruction to make your processor understand about the complex instructions. So your hardware designing also will be very complex, right? You will have very complex design overall. Fine. Then higher power consumption. So because you have a complex hardware design, then obviously the power consumption will be more here. I hope you understand that. So that was all about CISC architecture in short. Now we will see about RISC. Now you will be able to understand the difference between CISC and RISC. So what is RISC? The same example I am taking again. I want to perform C equals to A plus B. Remember, to perform C equals to A plus B in CISC, how many lines of instructions I have written? 3. But here how many lines I have to write? See, first I have to load the content from main memory to some registers in processor. Similarly, I have to load the second element also. Then I can add it. Finally, I can transfer back to main memory. I cannot directly operate on the main memory itself. I have to load to some registers, then I can operate. Understood that? Similarly, the same example you will see the multiplication one. Whatever multiplication we have seen for CISC, only one line was sufficient for that. Can you remember that? One line of instruction was sufficient to let our processor know about the operation multiplication. But here in RISC, we cannot use some keywords like mult. This is not allowed in RISC type of architecture. Now overall, how it will look like? See. First, I have to load the content from location this to A. A is nothing but a register here. Don't be confused. This is not a memory location. So what I have to do from memory location 2 is to 3 means second row, third column, whatever it was there. I have to load to some register A in our processor first. Similarly, the second data or second number also I have to store into some register B. After registering, I can perform the multiplication by using the keyword prod or mul, mul. So if you use prod or mul, A comma B, this is nothing but A is also a register, B also a register. Whatever they are inside A and B, it will be multiplied. And finally, the final result will be stored in A. This is nothing but A equals to A into B. Now you want to transfer the data to main memory. So what you have to do is store. This is the memory location where you want to store back the result. From where? From register A. Now see the difference. In CISC only one line was sufficient, but in RISC we have 4 number of instructions. So number of instructions are more in RISC. Now here students make a common mistake. They just see the full form of RISC and CISC. The full form of RISC is reduced instruction set computers. So they think that this is reduced instruction set, so I have less number of instructions. No, this is just opposite. In RISC I have more number of instructions than CISC. Just because reduced is there, don't think that I have less number of instructions. This reduced instruction set computer means I have less number of complex instructions. You understood that? So complex instructions I am reducing, not the overall number of instructions. The overall number of instructions I am increasing. That's clear? Fine. Now at first, it may seem like a much less efficient way of completing the operation, right? At first, it seems like this will take more time. This is not a feasible way to perform the operation. CISC is far better than RISC, right? It feels like that. But in reality, because there are more lines of codes, more RAM is needed. First of all, more number of lines, so I need more RAM. And the compiler must also perform more work to convert a high-level language statement into code of this form. Means I have many lines of instructions, right? So my compiler also need to work a lot. And RAM also I need more because I have more instructions to be added. So overall, it seems like it will take more time. This is not a feasible way. CISC is far better than this, right? It seems like that. But in reality, the RISC strategy also brings some very important advantages also. It's not that all the disadvantages we have in RISC. Because each instruction requires only one clock cycle to execute. Please note a point. Since I have very simple instructions, that means in each clock cycle, you can execute one instructions. In one clock cycle, one instruction can be executed in RISC, but in CISC, it may not be possible. In CISC, it may take 3, 4, 5 clock cycles to perform a single instruction. But here, one clock cycle is sufficient to execute a single instruction. So overall, it will take almost somewhere same time only, because you are using mult in CISC. Mult will be performing almost same operations only. Just you are not writing it, but in background it will perform the same operation only, right? It will take the value from both the locations, it will do the multiplication, then it will store it back. So overall it's almost same. The overall time requirement is almost same in both the cases. Fine. So this RISC reduced instructions require less transistors of hardware space. Now my hardware design is simpler than the CISC designing, because I have very simple instructions to be executed. That's why I need less transistors overall. So instead of using many transistors, here we use many number of general purpose resistors. We can have many number of GPRs instead of transistors. Because all of the instructions execute in a uniform amount of time, pipelining is possible. What is pipelining? Please forget this point as of now. We'll discuss in future classes. Pipelining will have a separate video. What is pipelining? Fine. Now there are two characteristics of RISC instructions. You can note it down. One is each instruction fits in a single word. Now remember, for CISC I said each instruction, to store a single instruction, I may need more than one word. I cannot always say that I need one word to store one instruction in CISC, but in RISC it requires only one word to store one instruction. Fine. Then a load store architecture is used. In CISC we used move, right? Whenever we wanted to move something from here to there, we used move. But for RISC we use load and store. Load means from main memory to register. Store means from register to main memory. Fine. Okay. So next we'll see some other features of RISC. RISC processor use 1 clock per cycle. As I told you, one clock cycle is enough to execute one instruction, because this is very simple. The RISC processor used the pipelining technique. Pipelining technique was not possible for CISC, but for not possible. It's difficult in CISC, but in RISC it's very easy to use pipelining technique. What is pipelining? We'll discuss in the upcoming videos, so forget about it. RISC has a simple addressing mode. Addressing mode also, please skip as of now. In the upcoming videos, very soon I'll upload one video on addressing modes. So it uses load and store, whatever I said. Now let's see some of the advantages and disadvantages of RISC and CISC. What are those? RISC, if I talk about advantages, simpler instructions. As I said, instructions are very simple. Faster execution. If I talk about a particular instruction, then overall RISC can execute a instruction faster than a single instruction in CISC. We have already seen, because a single instruction in CISC means multiple operations, so it may take longer time than RISC single instruction, right? Lower power consumption. Why lower power consumption? Because hardware designing is simpler than the CISC, so I need lower power. And disadvantages: more instructions are required. To complete a program, I need more instructions to be written, right? Increased memory usage. Since I have more number of instructions, I need more memory to store the program. Higher cost. Now, please note, I said higher cost. How it's possible? Our hardware design is simple here. Then why I am saying the cost is higher here? Remember, whenever we talk about hardware cost in computer, then main memory is one of the most costliest hardware. Fine. After that, cache memory is much costlier than our main memory. Fine. Whenever we talk about resistors are the costliest memory we have. So overall cost of resistors are more than any other simple hardwares which we use. So although the hardware design is simple here, but number of resistors I need more, because every time I have to store in resistors, then only I can perform the operation. I cannot access data from main memory directly in RISC. So overall cost will be more here because number of resistors are more. Fine. So there are some differences. If you search in internet, you will find n number of differences. So you can go through it. So first difference they have mentioned as full form only. Then the microprocessor is designed using hardware control. This one is microprogram control. Again, what is hardware control unit and what is micro program control unit? Skip this point as of now. We'll discuss these things in the upcoming videos. It executes at least one instruction in one clock cycle, several clock cycles are required. All these points are already discussed. The instructions have simple fixed formats with few addressing modes. The instructions have variable formats with several complex addressing modes. Addressing modes also please skip as of now. It has several general purpose registers, less number of registers. The instruction set of RISC microprocessor typically includes only register to register, load and store, and here we can access to memory also and register also. Pipelining is very easy to implement in RISC. It's very difficult here, so you can skip pipelining also as of now. So that's all about RISC and CISC architecture. In the upcoming videos we will discuss about some more topics. So if you like the video, please do subscribe the channel. Thank you everyone for watching my video.